Hello, welcome back to my channel. So today I'm going to be teaching you all about quantum computers. We are going to look at what they actually are, how they work, and where this idea came from. So basically, back in the 1980s, legendary physicist Richard Feynman realized that nature, things like atoms and molecules, were too complex to be processed by normal computers. So he thought of an idea, and that idea was basically quantum computers. So yeah, that's how quantum computers came into existence. But the question arises, what is quantum computer? What is this thing and how does it work? So in this video I'm going to be explaining you that in a simple way. So imagine you are trapped inside a massive maze with thousands of paths, okay, a huge maze, and you need to find the exit. So, what a normal computer would do is it would brute force. Like it will first go down, let's say, path A, it will go. If it's the exit, then great. If it's not, then it will go to path B, then path C, then path D until it finds the exit. So, this is great for everyday work and it gets the job done. But the problem is it is extremely slow. You have to manually calculate and go to every single path until you find the exit. That's very slow, obviously. So here comes the quantum computer. Now, instead of walking down one path, the quantum computer splits itself so that it can go to all the 1,000 parts at once. Yes, so it basically goes all into all the 1,000 paths at once and finds which path has the exit. After that, it can exit. Now, what quantum computers is, it just doesn't guess, it doesn't wait, it looks at the entire problem at once. Or you can imagine this analogy as a staircase. A normal computer would go step by step on the staircase, while a quantum computer will be at all the steps at once. So it doesn't really need to check all the path at once, it can see all the path at once at the same time. So basically, this quantum computer works on qubits. To understand what is qubits, we first need to understand how does a normal computer works. So basically, a normal computer or our phone, laptop on the devices runs on bits. Think of these bits like standard light switch. It can be in two positions. It could be turned on or it could be turned off. In computer language, we call this 1 or 0. We can also call this binary code. You have seen those videos or stuff where you can say hello, it could be in like 11000. So you can say the language of computers is binary code. So every app you run, every video you run, it's just bunch of light switches turning off and on, which translates to bunch of ones and zeros. Those ones and zeros are later calculated and give you an output in human language, that is English or your mother tongue. Now, a quantum computer doesn't really use electric switches like in normal computers. It uses actual subatomic particles like electrons. Now, these electrons are so small that they don't really act like a light bulb where they have a definite value of 1 or 0. Instead, they are more like a spinning coin. How? You know, when the coin is spinning, you don't know it will land on heads or it will land on tails. Both the positions are equally probable, and it's more like a blurry thing. So in normal computers, that spinning coin can either be a head or tail, but when you flip the coin and it is spinning, is it head or is it tail? It is like blur, both states at the exact same time. This is what we call superposition in physics. It means that a thing can occupy two states at one time. That is called a superposition. So because qubits can be blur of 0 and 1 simultaneously while they are spinning, through a calculation, a quantum computer can hold a massive amount of data at once. If you just have two regular bits, they can only represent one number at a time, like 0, 1 or 1, 0. But two qubits can hold four numbers simultaneously. So like you have 1, 1, 0, 0, 1, 0 and 0, 1. You see the difference? In bits, you can only hold two numbers, 0, 1 or 1, 0. While in qubit, you can hold 0, 0, 1, 0, 0, 1 and 1, 1. And imagine if you just get 300 qubits, then they can hold more number of the exact same time that there are atoms in the universe. While even with millions of bits, we cannot really calculate to that amount of speed, but with only 300 qubits, we can get that large amount of calculations, more than the atoms in our universe. But now, before you get too excited, this doesn't really mean you will be buying a quantum iPad anytime soon. Why? Because these subatomic particles are so sensitive that if a single atom of air bumps into them, or if the room gets a tiny bit too warm, the coin stops spinning. The calculation crashes and the whole thing turns back into a regular computer. That's why real quantum computers look like giant golden chandeliers. They are actually massive refrigerators keeping the quantum chip cool, colder than the deep space, just to keep the qubit spinning. You basically need to keep them in a very cold state and in more like a perfect vacuum there, where no particle can interact with them. And because so much heat is generated, we need to keep it at near absolute zero temperatures. And they are very delicate, so you cannot really use them to scroll Instagram. But where are they used? They are used in calculating very large prime numbers. They can be used to solve problems like creating a new medicine or a new material or running simulations. It's not really good at playing Genshin Impact. Alright guys, that was for the video. Thank you very much. Please let me know if you have any other topics which you would like to learn. Thank you very much. Bye bye. See you in the next